Chapter 9.4, Area of Parallelograms and Triangles. So our vocab is really two words, but looking at it for two different shapes. We have base and we have height. So we're going to focus first on a parallelogram. The base of the parallelogram is typically the bottom, okay? It is what the shape, the side the shape is resting on. The height is the vertical distance between the top and the bottom. It's as if I take a string, a ball of string, and I hold on to one end and I drop the ball. It's going to fall straight down and make a perpendicular angle with the base. This side is not the height, okay? It's not the height. That's the length of the side. The height is the vertical distance between the two. So the formula for finding the area of a parallelogram is area equals base times height. So let's take a look at example 1. Find the area of this parallelogram. So I want you to start by writing the formula. Area equals base times height. I see that the base equals 5 meters. My height, the vertical distance here, is 3 meters. So my area equals 15 meters squared, or 15 square meters. Note that the square symbol goes after the exponent, goes after the meters, not before it. So the area of this parallelogram is 15 meters squared. All right, now you might ask yourself, well, why does this work? So think if I took this shape here, this triangle, and I cut it off. If I was to cut this off, I could move it over here onto this side, and it would fit perfectly right here. If I looked at my new shape then, my new shape would be a rectangle. The base would still be the exact same length because I just take this piece, this length, this part of the base here, and move it over here. The height becomes the side of my rectangle, and so I can use that vertical height or that side to find the area. So we find the area of a parallelogram pretty much the same way we find the area of a triangle, or a rectangle, sorry, not a triangle, rectangle. We just use the vertical height. We do not use that side. All right, let's take a look at example 2. A conservation group has plans to buy a triangular plot of land shown at the left. What is the area of the plot? So area of a triangle is 1/2 times the base times the height, or base times height divided by 2. So you need to be able to identify both the base and the height of the triangle. Any side can be the height, or I'm sorry, any side can be the base of the triangle. For this triangle here, we're using this side as the base. The height, just like the height of a parallelogram, is the vertical distance from the opposite point up here. If I drop that ball of string straight down so that it makes a right angle with the base, this is the height. The other two sides are not the height. Okay? No. The height is the vertical distance. So in this case, my base equals 30. So if I were to solve this, area equals 1/2 base times height. So equals 1/2 times, my base is 30, times the height, which is 10. 1/2 times 30 is 15, because that's the same as 30 over 1 times 1 over 2. I cross cancel. I get 15. 15 times 10 equals 150. Double check your units. Okay, I'm using kilometers this time. So 150 square kilometers. Okay, so looking at example 3, we're going to put this together. Here I have this funny shape. Okay, it's labeled with all sorts of different lengths and widths, and I want to find the area of the entire figure. So in order to do that, I need to break up this figure into shapes that I know how to find the area of, namely rectangles and triangles. So I can see I have one shape right here. I have a triangle here. If I look at my dimensions, it's telling me that the distance here is 2 inches, which means that this distance up here is also 2 inches. And it is 3 inches tall. Inches. So the area of this rectangle right here is 3 times 2, or 6 inches squared. Now notice that I took the shape and I copied it, blowing it up, making it bigger, but I copied it into my work area. I'm going to recommend that you do the same so that you can label it, break it apart, figure out what you're going to do with it. So I found this rectangle. Now I see I have another rectangle here. So I have this large rectangle, and then I have a triangle over here. So I'm going to start with my rectangle here. So I see this bottom piece here is 4 inches. And now I need to figure out the height. Okay, what is this distance? So I see here, this is 2 inches. This whole piece is 3 inches. So together, this whole length is 5 inches. Okay, so that's this whole length right here. 5 inches. So the area of this rectangle this area is 20 inches squared. Okay, so now let's take a look at my triangle here. So I know this is 5 inches, this length right here. That's my base. My height is this vertical distance here. So I know, looking at this shape over here, this distance is 3 inches. This distance over here is also 3 inches. So remember, the area of a triangle equals 1/2 times the base times the height. So 1/2 times 3 times 5, not 15. Getting ahead of myself there. Okay, I'm going to multiply 3 times 5 first. So 1/2 times 15, and half of 15 is 7.5. So this area is 7.5 inches squared. So to find the total area, we're just going to add. So area equals my 6 inches squared plus the 20 for my large rectangle plus 7.5 for the triangle, which equals 26 plus 7.5. 26 plus 7.5 is a 7. 5, 13, 1, 3. So my total area is 33.5 inches squared. So yes, there are a lot of steps to these, but each step by itself is not necessarily difficult. Okay, the biggest challenge is making sure that you know all of your dimensions that you need in order to find the area of each piece. Okay, that's it for examples. Go ahead and do your QCs and CYUs, and I'll answer questions next time I see you.